Exercise 12.3, 4th, 5th and 6th questions. Fourth question, find the area of the shaded region where a circular arc of radius 6 cm has been drawn with vertex O of an equilateral triangle OAB of side 12 cm. So, full figure is shaded, so you have to find the area of the triangle plus area of this part. So, what you can do? What we can do is area of the triangle plus area of this full circle minus area of this part, this sector. Area of the triangle plus area of the circle minus area of this sector, because it is coming twice. Otherwise, area of the triangle plus area of the circle means this part is coming twice. So, you will have to remove 1. For that we are subtracting minus area of the sector. So, what we can do here is required area is equal to area of the triangle plus area of the circle minus area of the sector. Area of the triangle, equilateral triangle. So, what is the formula? Root 3 by 4 a square. Area of the circle, radius is given as 6 cm. So, here the radius is given as 6. This is the radius. So, pi r square we can use. Then area of the sector. What's the formula of area of the sector? Theta by 360 into pi r square. R is 6 itself. Then what about theta? Theta is 60 because it is given as equilateral triangle. So, we can do the problem. So, area of the triangle is equal to root 3 by 4 a square, which is equal to root 3 by 4 into 12 into 12. And what about area of the circle? Area of the circle is equal to pi r square, which is equal to 22 by 7 into r is the radius, 6 into 6. Then area of the sector. Area of the sector is equal to theta by 360 into pi r square. What is theta? 60 degree, because it is an equilateral triangle. 60 divided by 360 into 22 by 7 into 6 into 6. So, what we can do here is, you can substitute the values here. So, you will get this as 62.38 plus 113.12 minus 18.85, which is equal to 156.65 centimeters square. You have to do the calculation. So, required area is equal to area of the triangle plus area of the circle minus area of the sector. Then 6th question. No, 5th question it is. 5th question, question number 5. From each corner of a square of side 4 cm, a quadrant of a circle of radius 1 cm is cut, and also a circle of diameter 2 cm is cut. So, 4 quadrants are cut from this of radius 1 cm. So, 4 quadrants means 1 circle. What about here? Again 1 circle. Then what about the radius? 4 quadrants of radius 1 cm. What about this radius of the circle? Radius of the circle is, diameter is given as 2 cm. So, radius is clearly 1 cm. So, what we have to do is, required area is equal to area of the square minus area of a circle of 2 times area of a circle of radius 1 cm. So, we can write this as, what is the formula to find area of the square? L into L, or side into side. What is the side here? Side is given as 4 cm. So, 4 into 4 minus 2 into pi r square. 4 into 4 minus 2 into pi r square, which is equal to 16 minus 2 into 22 by 7 into 1 into 1, which is equal to 16 minus 44 by 7, which is equal to 112 minus 44 divided by 7, which you can find 112 minus 44 divided by 7. So, it is actually 68 by 7 centimeter square, which you can find the decimal form. You have to find the decimal form because 3 mark onwards you have to get the final answer in decimal form. 1 and 2 marks you can keep the fraction as it is, but 3 and 4 marks you have to convert it as decimal. So, the question is, from the square 2 circles are taking out. So, the remaining part, the area of the remaining part is area of the square minus area of 2 circles. Then this question, in a circular table cover of radius 32 centimeter, a design is formed leaving an equilateral triangle ABC as in middle as shown in figure. Find the area of the design. Here we have to find the area of the design. For that, I am drawing the circle again and I need to get an equilateral triangle. So, I am marking this as A, B, C. And what you have to find is area of this part. So, area of this part means area of the circle minus area of the equilateral triangle. So, required area is equal to area of the circle minus area of the triangle. Area of the triangle. What type of triangle it is? It is an equilateral triangle. So, what is the formula to find the area of the equilateral triangle? Root 3 by 4 a square. We are using that. But here, what is given actually? Only radius is given. Only radius is given as 32 centimeter. You have to find, and what else is given as equilateral. Only these two things are given. So, I am writing this. Radius is given as 32 centimeter. So, using this radius we can find the area of the triangle. Sorry, area of the circle. So, what about the triangle? For getting the area of the triangle, we need one side of the triangle because it is an equilateral triangle. For that, what about each angle of this? All these angles are 60 degree. What I am going to do is, I am going to draw a perpendicular from the center to this chord BC. So, I am marking this as OP and I am going to draw this. If OP is the perpendicular, what about the angle made by this? OBC or BOC. Angle BOC is equal to, look here, angle made by this arc at the center, and this is the angle made by this arc at any point on the circle. You have already learned the relation. What's the relation? Angle made by an arc at the center is double the angle made by it at any other point on the remaining part of the circle. So, this is the angle made by the arc BC at the center, and this angle is the angle made by the same arc at any point other than the center on the circle. So, the relation is, this is the double of this angle. That means, Angle BOC is equal to 2 into 60, which is equal to 120 degree. And what I have done is I have drawn the perpendicular here. Draw OP perpendicular to BC. If OP is perpendicular to BC, we have already learned these two triangles are similar using, congruent using RHS criterion. So, triangle BPO is congruent to triangle CPO. So, what we can say, each of this equal to 60 degree. Angle BOP is equal to angle COP is equal to 60 degree using CPCT. Then we have to, actually what we need is the side of a triangle. So, from this triangle, from one of this triangle, we can find this side. If you get that side, we can find the full, because it is a perpendicular from center to a chord. So, it is actually double. So, what we can say is, we can use is sin 60 we can use, because we need this. What is this actually? These two are 32 centimeter, because that is the radius of the circle. This is 32 and this is 32. So, we can use sin 60. Sin 60 is equal to opposite by hypotenuse. Which is the opposite side of 60? BP. BP divided by 32. So, sin 60 is equal to BP by 32. So, root 3 by 2 is equal to BP divided by 32. So, BP is equal to 32 divided by 2 into root 3. That means 16 root 3. If BP is equal to 16 root 3, what about BC? Total BC is equal to double of this, because the perpendicular drawn from the center to a chord bisect the chord. That is the reason. Perpendicular drawn from the center to a chord bisect the chord. So, what we can write is BC is equal to 2 times 16 root 3. That means 32 root 3 itself, using perpendicular drawn from the center to the chord bisect the chord. When you write the answer, you have to write the reason also along with that, otherwise you will lose the mark. So we got one side of the triangle. So, we can find the area of the triangle. What is the area of the triangle? Area of the triangle is equal to root 3 by 4a square. So, which is equal to root 3 by 4 into 32 root 3 into 32 root 3. So, same way, area of the circle is equal to pi r square. R is given 22 by 7 into 32 into 32. So, you have to find the remaining part. What is the remaining part? Area of the required area is equal to area of the circle minus area of the triangle, which you have to do as homework.